Hi.
Wait, no, you cannot.
Hi there.
No,
Hold on.
it's loaded.
Okay, we're trying to get this going. This is our first live stream. Hi there. I'm Alex, and this is Sebastian.
Hi.
And we are with Pressure Games, and this is our first live stream for Tech Tuesday. I really hope things are working, and certainly if you can if you're watching this right now, send a comment just so we know that we're actually live, because this is new to all of us. We are doing a presentation here on circuit programming, and the goal is to try and get you to understand a little bit more about electronics and how to make some really cool projects that you can do at your home, no matter what your age. We want to make this an introductory class, so we are going to take it baby steps this class, but we already have a plan for what we're going to be doing on the next class, and so I'll show that to you here. Basically, this is using a board with a bunch of wires on it, but we have this little robot who really wants people to love him. And there's a sensor here that when you get close to it, it shows you a heart. And if I tilt it up here so it's aiming far, far away, the robot gets sad. And if I tilt it down so it's aiming it at my camera, you get a little heart. And so this is something we're going to work on in the next class, and I think it's important for you to understand where we're going to go. So this looks complex, and there's a lot of programming that goes on in here, but by our next class, in 30 or 45 minutes of this introductory class, you're going to be able to build something like this on your own, which is really cool and a lot of fun.
Yes, it is.
So I don't know if you have an electronics kit at home. I have been.
Pressure Games says hey, hey, hey. And Adrian Andre says Sebastian looks good.
Well, that's
Thanks.
great. I like these comments. We have our director over here, Alexis, who will be doing our directing and reading comments out to us.
Hi,
So
I'm Adrian.
feel free to send any shout outs as
And
you
Miss
want.
Liz.
And
And probably Mr. Nilesh.
all right. I'm going to disconnect this board right now. Hopefully that looked pretty neat as far as where we're going to go. And right now we're going to start talking a little bit about electronics and circuitry. So the board we're going to be using is, you want to hold this one up?
Sure.
You can hold it in front of the webcam. Actually, let's hold it in front of this one.
Okay.
So this is called an Arduino board. The really cool thing about this is it's very easy to program. You might not understand all the things that are going on this board, and honestly, I don't understand every single part of it.
I don't either.
But the point is that you can plug it into USB, you can program it through your computer, and you can have it control other devices. Okay. Our director is being pulled away right now. I don't know if we're having technical difficulties, but hopefully you can still see us. So,
Can you? Comment if you can.
okay, so, no, stop.
Actually, no.
They'll send comments if they want.
Yeah. Okay.
So we are going to learn to program this, and we're going to make a circuit. And the important thing to understand about a circuit is how electricity works. A circuit is when electricity flows through a couple devices and makes them do something. So that can be turning on a light, that can be making sound, that can be responding to a button
We're
press.
turning on that orange fan.
It can be turning on the orange fan, which is also in the kit that we have, but we're not using that today. So the important thing, everyone's seen a battery before. There's the top of the battery and the bottom of the battery. This is where the electricity comes out. The plus side is where the electricity comes out. If you look at anything that does electricity, like a plug socket, there's two prongs. In a USB cord, you might not see them, but there's little pieces in there where the electricity comes out.
Wait, really?
Everywhere,
Oh.
everywhere that uses electricity, there's always at least two wires going into it, and it's just like a battery. The electricity comes out one side, goes through and does some things, and then it goes back into the bottom of the battery. If you don't have that full connection, nothing is going to happen. You can't just connect something to the top of the battery without connecting to the bottom. And
Because the electricity needs to flow.
that's right. It needs to flow. It has to start. The way I always think about it, and when I was in school, the way that I learned that was the most interesting way, is electricity is sort of like a water slide. At the very top, you get off and you slide down the water slide, and it might branch out. The water can go a bunch of different directions to turn on lots of different lights or turn on lots of different sounds. But eventually, after that's all done, all that water is going to come back up, pool at the bottom of the battery, and be ready to go again.
And for water slide, it's a drain, and then it goes through the pipes and comes back up.
And that's sort of like the plumbing inside the battery here. That's a really good example. And so we're going to learn how to control that water, that electricity, through a circuit. And so we're going to take this Arduino board, and now we're going to go over to here, and I'm going to have Sebastian, our little guinea pig.
I'm not a guinea pig. I'm not hairy. You were hairy.
He's going to set up this board.
I'm going to plug it in.
Actually, let's not plug it in yet.
Why? Either way, when you plug it in, it's going to be like this.
I'm going to show off a little bit more of the board. Are they viewing this right now? Okay. So if you turn the board over on its side, let's just go over the board really quick. And we got a lot of hands here, but that's okay. So
I'll just bring my hand up.
you'll see we're going to be using these black connectors right here. And you can plug wires into any of these little holes. And once you plug a wire into a hole, then you can connect it over to this board over here. And we're going to show how this board works in a second too. This board is just a way to extend and add on to the Arduino board. So some of the more important pins we have here are 5 volt and ground. 5 volt is like the top of the battery. It's 5V. That's where the electricity comes out of this board. So everything that we're going to power, it's going to come out of 5V, go into a light, go into a sound, go into the display that I showed you earlier, and then eventually we need to have another wire that comes back from that part to ground.
Are we going to talk about input and outputs today?
We'll talk about that in a little bit.
Okay.
We have not fully scripted this, guys, so bear with us. But again, hopefully we're going at a pace that makes sense. But if you have questions or if something I'm saying doesn't make sense, let me know. Okay. So we're going to start here. Sebastian, what I want you to do is I want you to take this wire and put it into the 5V. Now we're going to use a red wire here because red usually indicates power.
Yep.
So we stick that into the 5V, which is for power, and then we're going to put it into the red part over here.
Does it matter which row it's in? Which thing it's in?
That's a good question. It doesn't. As long as it's over here, if you put a wire in here, so let's put it in any one of those red ones there.
Even
You
not
can put
those?
it anywhere you want.
Anywhere?
Pick a wire, please. All right. So now 5 volt electricity is coming out of here and going into here. And the way this board works is all of the pins in this column right here now are connected to that same pin. So all of these, where this red line is actually going to get electricity when we power the board.
And can we put another wire here and put it in this row and then we can power it?
Let's slow down, but yes, that's what we're going to do. So now, instead of having to do one pin to a bunch of different lights, now we have one pin coming here, and we can use the electricity coming out of any of these pins to power something else.
Any of the red pins on this side, not this side because there's no flowing energy on here.
Correct. And these are separate. So this red right here ends right here. So this section is all connected together, but this section over here is not connected to anything
So
right
if we
now.
put a new one in, it still wouldn't work because it isn't on the 5V power volt?
Correct. We'd have to connect it. You can connect them just by putting another wire in between these two. That would work.
Okay.
Now what I'd like you to do is put a pin from ground to the blue, and you'll see
Does
it.
it say GND?
GND is ground.
Does it matter which one it is?
Nope, they have two there. You can use either one you want.
Okay.
And soon here we're going to be turning on a light.
Yeah. Red light?
And now let's put that into the negative area over here,
Negative.
which is ground. Is it not working? Oh, hold on. You're going to have to do that refresh cache thing. Let's do it again.
Is it working?
Mommy says we're not going live.
All right.
Wait, Mommy's watching?
Okay.
Is it going?
Okay,
I
back?
can see tape.
Okay, tape's fine.
Good. That's fine.
Still.
Okay. So,
Oh,
what's
I
wrong?
can see like the edge of your board.
Is that better? All right. Let's try that. Okay. So now we've connected power to power, and we have our green ground to this negative over here. Hopefully everything is going well. The next thing we're going to do is, if you have the electric case over here, we're going to pull out a light. What color do you want to use?
Green.
Okay, we're going to use green. Now, there's a really important thing here. Again, electricity is sort of like a water slide.
Do we need the,
Hold on, wait 1 second.
the things that slow the
Yes, we're
electricity?
getting there. So, water slides are really fun when they're gradually going down. If you connect power to ground, you have one of those water slides that's like straight down, that terrifies and scares, and you might like those, but electricity does not like going straight down. So we don't want electricity, we don't want our red wire and our green wire, our power and our ground to connect to each other, or we have what's called a short, and that's a bad thing. So
It's like an electricity shortage in your house
Yep.
if the power goes out?
it is electricity shorting. I mean, whether it's electricity out of a board here or out of something else, it's electricity shorting, and that's bad. So in the electric packet, there's these things, these little blue things, and they're called resistors.
Oh, yeah.
Resistors resist electricity. They slow it down. So now your water slide, instead of going straight down, if you have a resistor in there, it's sort of making it into a lazy river.
An angle.
And so when we're plugging in a light, we want to slow down the electricity, because if the electricity goes straight through this light, it can hurt the light. We want to slow it down before it gets there. So what we're going to do, there's 2 pins you'll see on here. One's a little bit longer than the other. The longer pin has to go into ground, and the shorter pin we're going to put anywhere you want over here in any one of these.
So,
And you'll have to bend the wires, it's okay. The wires out of the light are fine to
Okay.
bend.
does everyone see that? Good.
Let's hope they do. And then if you go through all of these little resistor packs that came with your project kit, you can see at the very top, some of them have a number written on there. This one's really hard to see, it's poorly printed, but this one says 220. And so 220 is a low number. It's going to resist a little bit. There are some that go up to 1M, 1 million. That resists a lot of electricity.
And does it make the light dim or bright?
If you used a 1 million, you wouldn't see the light at all. There would not be enough electricity getting to it. It would resist so much electricity.
Okay.
So now we have one more step in this process. We want to put this resistor from power to the other pin of our light. So we have from the red wire,
And do we do it in the same line?
and we do it in the same, now we do it in the same row as the light.
This is column. This is a column. Up and
Or
down is column.
Okay.
Just so you know.
So now, if you look at this, we have electricity coming in here. We're going to follow this chain through. The electricity comes in here. It's going to go into this resistor, which is going to slow down that electricity.
And then would it turn on? It would go up, turn on the light, and then it would come into ground, flow there, and just keep going.
That's the hope. Let's see if we got it right. So now if we plug this in through USB, hopefully we get a green light here. We did not get a green light. What did we do wrong?
Coding.
No, there's nothing to code yet. Let me see. Sometimes, I don't think I swapped that. Oh, I did. I said the wrong thing. This long post here, I said the long post should go in the ground. This is actually where the electricity has to enter. So you might need to switch your light around if you followed my directions, which would be understandable. And so we're going to put the longest pin here with where the electricity comes in, and the shorter pin is going to go over to where
Oopsies.
the ground wire is.
Okay. But if we unplug this,
Yep.
it would stop.
Anything you unplugged here is going to break that circuit. Again, the water slide, the water's not going to get down to the bottom, and there you're not going to have a circuit.
And if the ground wasn't plugged in, it would just all pool up on the ground, and you would have to keep getting water and...
We can't take the water slide analogy too far, but yes.
Yeah, okay.
So
Whatever.
now we have a basic circuit. We don't have any control of the circuit. The power is just always on,
But if we unplug this, the computer isn't giving power to it, and
Sure.
it'll turn off.
Again, that stops the circuit. If you look at this from the longer view, the computer is sending electricity in here, which that is part of the circuit too. The electricity comes in here, goes out through here, turns this light on, leaves here, and then has to go back out the computer.
But why does it go out back to the computer when it can just keep circulating
Because
around?
this is where the power is coming from. You always have to keep following the power back. And eventually it gets back to my computer, which is either plugged into the wall or it has a battery of its own.
Yep, it's plugged in and it already has batteries.
So, but that's how it works. You always have to follow the electricity back, and wherever the power actually starts, you need to have that connection to the end. This doesn't have a battery on it, so if you unplug this USB, there's no electricity that's able to flow here.
Any comments yet, Alexis?
She'll tell us.
Okay,
So
just asking.
the next step we're going to do is we're actually going to program this board. And the most important thing is if you have a toy or you have a computer, you have anything, you want to be able to control what it's doing. Right now, like I said, the power is plugged right into the light. We don't have any control over this other than unplugging it.
Like for some robots, you push the forward button and then you would push the right button and it would go forward one, then turn right.
Sure, all these things.
Yeah.
All toys that you have that are robotics or that use a remote control, they all use some variation of this. And that's where, like I said, we're going to get into where we're actually programming boards to make hearts and to react to things that are too close or too far away, or use buttons. We can do a lot of different things. The first step is understanding how a circuit works and turning on a simple light. And once you can do that, you can do just about anything. It's just making it all work together. So the next step, like I said, is to actually start the programming process. We sent out a link the other day for a program called PictoBlock.
PictoBlocks.
Hopefully you've seen this. It is from the Stempedia.
I just said
Stempedia.com. The Stempedia.com. The Stempedia we have no relationship with, but they have some really cool add-ons that you can buy. If you get really into this, I'd highly recommend looking at it. They provide this free programming tool, which again, we're going to use today, and we're very appreciative that they make it available. So I definitely want to send a plug out to them. But again, we're not affiliated with them at all, but we're definitely thankful for what they've done. My director's waving her arms around a lot at me right now. But now she's hiding behind a chair, so that's okay. Okay, so we are going to use this, calm down. While we're using PictoBlocks, we can actually tell it we're going to program an Android. Now, PictoBlocks uses Scratch, which you may have heard of Scratch, you may not have. But programming languages, if you've ever looked at a programming language, it looks like gobbledygook, and it's very hard to understand what any of it is.
I would prefer Scratch because you have to learn a lot just to turn one light on for gobbledygook.
And we'll show you we'll show you what that code actually looks like in a second. Scratch is really nice because there's a drag and drop. You can drag and drop and say, I want to do this, and it handles it all for you. So if you have PictoBlocks installed, this is the opening screen that you're going to come up with. And what we want to do is we want to go up to the board up here. You can't see me. Are you on the correct view for?
Yes.
Can I see which we're on? 1 second. Technical difficulties. What can't you see?
I don't know if that
This
was
is what
the
we
right
want.
one.
That's the right one.
That's the right one.
Okay, so we want to come up here to board, and we're going to select the Arduino Uno. If that's the board you have, the one that we were just showing off, they can't see it. If you have the Arduino Uno, which is the board we've been recommending, you select Arduino Uno. And when you do that, it may ask you to plug it in, which is ours is already plugged in.
I'll plug it in a little more.
Okay. And it'll ask you how you have it connected. Usually it's going to say USB, or it might even show Arduino. It might show a couple different things, but we're going to connect to it here. And when we connect to it, we have all these different tiles over here, all these little blocks that we can use to drag and drop. And so I would recommend one last thing before we actually get into the coding portion. There's a mode switch up here. Stage is for showing this little panda bear, which you can choose to control with these blocks. You can make him walk around and stuff.
Instead of the Arduino Uno.
It's good for learning how to program, but we're gonna use the electrical board. So let's go and click this. Instead of stage, we're gonna go to upload. So that just gets rid of our little panda friend. He was a nice guy, but we're gonna say bye to him now.
Bye-bye.
Now over here we have a bunch of different blocks. There's control blocks, there's operators, and we'll go into what a lot of these different things mean, some today, some in future classes. The most important right now is Arduino Uno. We want to go here, and the first block that every project needs is when the Arduino Uno starts up. And so we bring that over here, and that just says here's the start of our program. And you can look over here in this side, and this actually starts to do all the code for you. So code is actually being generated, but it's so much nicer to drag and drop when you can.
Yeah.
And then our goal right now is to just make this light flash. It's a simple task, but it really shows you what we're going to do. And
Why can't we just write flash? The code.
Because it's never that easy. We need a little bit more than that.
Flash and turn it on for 5 seconds, delay it for 2.
Let's get there.
Can we do that?
So if you go over to control, these are all the different ways that you can set up repeating actions. So we're going to use something called a loop, and it's going to be a forever loop. So just like it says, whatever we put inside of this block is going to happen forever. We can choose to do a block that repeats 10 times or 5 times or 2 times. So
you can write how much it does, right?
And so we'll show that. And so if you want to have it flash 5 times and then forever stay on, you can do that. There's a lot of different things you can do. And again, if you have different lights doing different things, some can flash, some can turn on for a long time, however. But we're going to bring this forever block over. And then we're going to go back to Arduino Uno. And here's where we're going to actually tell the light to turn on. So we're going to drag this block over here. It says set digital pin 13, and you can drop this down and pick which pin you're going to use and output it as high or low. So let's dig into this a little bit more. So this says pin 13. That's the default. I'm fine for using pin 13.
That's pin 8.
Okay. Slow down.
Pin
We're talking
8D, right?
Slow down. We're talking pin 13 from the Arduino board. It doesn't matter.
Yeah.
So if you can switch us over to the board view. So the way we're going to change this, now we take this red wire here that's coming out of power, and instead of coming out of power, we want to switch it to come out of pin 13. You can either see it on the side
so
here.
let's unplug this so I don't electrocute myself.
Okay, we'll talk about that in a minute. You're not going to electrocute yourself, but it is always safe to turn things off.
Turn power back on.
Okay.
Beep boop.
Oh, hold on.
Beep
It's
boop.
not black.
I have a phone that likes to...
Freeze.
Can you do the refresh thing now?
It's black.
Can you do the refresh thing now? Should work.
Can you see my face?
Okay, it's
Back
black.
up.
It's Russian.
Okay, so you might have missed it, but he took the red wire from the 5V, the power over here, and he put it into pin 13 over here. Now we have a light that's sort of flickering here, but that's because we have not programmed this board to do
And
anything.
it's flashing super duper fast, but
Yeah, I don't know what you can see.
you can see it flashing super fast
But-
here, but you might not be able to, you guys.
The important thing is we took, instead of having power constantly coming out of the 5V pin, we've put it over here to a pin that we can control. And so pin 13 is a pin that through programming we can say turn power on, turn power off. We can control it however we want.
It's an input, right?
And so let's go to the programming view and the
Would it be an
Board
input
view?
or output? I forgot.
that's a good question. I didn't talk about inputs and outputs. What? I'd say programming with board, yeah. So there's two different ways you can set up pins, but really it doesn't even matter in this. We're outputting power from this pin. So we're gonna set this pin up to where we can either control it to drive out power or not to drive out power.
Can they see us?
I don't know.
Okay.
The way, in the programming view, the way this works is we're gonna say set digital pin 13.
Because it's plugged into 13, we want it to control that pin, so it goes and controls
Yep.
that light. But if it said control number 8,
Yep.
this light would just be off.
It's whatever number we choose.
Yeah.
And we're gonna output it as high. Now high is just another way of saying on. So high just means that we're gonna send voltage out.
Hi.
And so, yes, high.
Hi.
Now we're gonna come back up here to control, and we can say, we can add another block here, we're gonna add it underneath, and we're gonna say wait 1 second. And then we're gonna come back over here to the Arduino Uno, and we're gonna take set digital pin to low. And
So
then
it's off?
let
That's
me
the
walk
off
let me walk through this 1 second. And then we come back over here and we add one more block. So if we walk through this, the Arduino Uno is gonna turn on. That just means we plugged in power. And then forever after this, we're gonna turn the pin on, which should turn the light on. We're gonna wait 1 second.
It stays on for 1 second.
Correct.
Okay.
So if we turn the pin on and leave it on for 1 second, then we turn the pin off. And then we leave it off for 1 second.
And then it just keeps looping around over and over and over forever.
Calm down, yes. What? Okay. And so now I'm gonna say connect up here in the corner, which I thought I already was. And then we can hit this upload code button over here. So
Can I
can they
push it?
Sure. Come on over.
Push.
And that should,
Push again. Push.
oh, there we go. And now
Oh,
we
and it
have,
blinks like 3 times really fast just to tell you that it's actually uploaded it.
yeah, while it's programming, some weird things happen. But now we program this board. We have turned a light on. And we have used some code to turn that light on. Now-
Mississippi 1. Okay.
Let me talk. All right, so the whole point of this is to show how electricity, now we have used a programming tool to control the Arduino board to turn this light on and off.
What is that orange light right there for?
I honestly don't know. Oh, I think that's connected to, pin 13 is a special pin that's also connected to this light here. So you can choose,
Okay.
even if we don't use this green light here, you can tell that you're controlling the board by turning on and off pin 13. So that right there is really all I wanted to get through today, because at this point we've shown how to use some wiring on the board, how to control it through programming, and that with controlling, we can make the board do whatever we want.
Can you show them how to make it blink longer and
Sure.
stop longer?
So
So,
you want to go back to the programming view real
you
quick?
see this?
Okay, great. Okay.
You see that? You can push it, push delete, and then push a different number. So you would keep it on for 3 seconds and turn it off for 1 second. Or you could do it like this. And I think I'm gonna do that. Upload code.
And that's perfect.
Let's see what happens.
An important thing to understand, especially with programming with Scratch, is that it's very hard. You can't hurt anything with this.
Unless
So-
you don't have a receiver, right?
Well, with the programming side, if you have the circuit set up right, you can tinker with this all you want. There's a bunch of if statements and else statements, and we're going to go into that with the Happy Robot, like I said, that we'll be making next week, on how to make things change depending on what's going on. If
Can they
something's
even
close,
see you?
okay, I don't know. If something's close, how about you come to webcam if they can't see me?
Webcam.
And so in the next class, we'll be going to program the Happy Robot. And so we'll make it to where if it senses that you're close, it'll show a heart because it loves you. And if you get too far away, it's going to be sad. And so we'll use those if-else blocks and we'll get things going properly there. Again, this board looks like a ton of wires.
Yeah.
The wiring it up is the hardest thing. The code you're going to think is really neat because in Scratch, I will actually open it up here for you. Let me open this up and we'll go to that view if I can.
The other one.
Hold on one sec. Not yet. Oh,
Friendly. You literally named the file Friendly Robot
I
Face.
sure did.
Friendly Robot Face.
Yep. Sorry.
Have you brought it there?
You have the, is it on? So
Webcam?
this is the code.
Is it on webcam still? Okay.
Stop.
Good.
So this code right here is all the code that we'll need to actually turn all this wiring into our friendly robot. And it'll turn on in just a second here. It takes a minute to warm up. But
Oh, and if instead of just doing Scratch, you would have
Yeah.
had to do
We're not-
all of
yeah, the code is really nasty. You don't want to do all the code.
this.
Scratch is really nice. Please sit back.
Wow.
So next week, we're going to talk about how to wire this up, all the different things that are here, but a lot of these tools came in the kit, and they're really neat. You can build things that sense things and turn on lights or make sounds, and so you can make something that will, anytime someone comes into your room, will make a buzzer noise, and it's
How do you
all...
do that? Is there like a sensor on the
We'll get there.
floor?
Well, just like this. If someone's close, it'll turn on the sensor.
Oh, but where would the speaker be? Is there even a speaker in the kit?
We'll get there. Those are all for future classes. I'm glad we have one really excited student. I hope there's others out there. That is it for this first class. I want to keep these at about a half-hour length because there's only so much to do, but this live stream will be saved and put on Facebook if you want to watch it again. This is our first test at this. I'm sure we made some mistakes, and I would love to have your feedback. If you have any comments or suggestions, please let us know, and we hope you'll tune in. We're planning on doing this every Tuesday at 1 o'clock.
So we'll see you next week.
We'll see you next week. As long as the kids are at home, we'll be doing this. So thank you so much, and
Bye.
enjoy.
That was fun.